We are recording this session and we'll make it available in a day or two through the link in the Teaching and Learning section of the Globe website. So you can see here that if you are on the Globe website, you'd go to the Teaching and Learning section and then click on Professional Development Resources. And then once you're on the Professional Development Resources page, you're going to click on the Webinars tab, and we have a special section for the Next Generation Science Standards webinars. And Kristen has been taking care of that for us, and she's putting the new webinar on top each time.
Hello.
Hello.
Hi. It's Dawn.
Hi, Dawn.
Hi, Dawn.
Our objectives for today are to provide U.S. Globe community members with an opportunity to learn about and discuss some of the conceptual shifts of the Next Generation Science Standards, and then to have a conversation about how Globe fits in with NGSS. As a reminder, this is a series of webinars, and we've covered 4 of the conceptual shifts already, those that are in green, 1, 2, 3, and 7. Today we're going to be covering conceptual shifts 4 and 6, and conceptual shift 5 we'll actually cover in the next webinar in October. So today we'll be talking about focus on deeper understanding of content and preparing students for college, career, and citizenship. Just a little overview of our agenda for the call today. The call will be an hour long, and we're going to discuss shifts 4 and 6. First, David will lead us through a discussion of how NGSS is a focus on deeper understanding and an application of content. And then I'll return and cover preparing students for college, career, and citizenship. And then finally, Kristen will lead us through the brainstorming questions that we've been using in the entire webinar series in order to bring us back to thinking about what does Next Generation Science Standards mean for Globe. And so now I'm going to turn over the mic to David.
Well, hi, everybody. My name is Dave Bydlowski. I'm a science consultant at Wayne Reese. We're an intermediate school district. We work with schools all over Wayne County, which is on the west side of metropolitan Detroit. So we service Detroit Public Schools and most of the schools on the west side of our area. If you've ever been to the Detroit airport, we're about 2 miles north of the airport. So it's nice to be here. Besides being a Globe partner, I've also been on the state of Michigan's review team for the Next Generation Science Standards. And our state of Michigan is in the process of adopting the Next Generation Science Standards, and hopefully that will be finalized within the next 2 to 3 months. So I've had the opportunity to spend quite a bit of time working with the Next Generation Science Standards. And one of today's topics is to look at the idea about deeper understanding and application. And as you'll see on that slide right now, there's this whole idea about novices and experts. And one of the big ideas of the Next Generation Science Standards, which are really an assessment document, not a curriculum document, is to really take students and move them from the novice level up to the expert level. But that takes a long time, and it's really a K through 12 process, and it's really important that science is taught at each grade level. And as you'll see here, as I mentioned, the novice to experts, you can read along and kind of see what are the steps of being the novices and what is the experts. But the idea of this novice and experts it came from a couple of different documents. One, I don't know if you're familiar with the book Taking Science to School, which was one of the research documents that was used in the development of the Next Generation Science Standards. And the book that I wanted to show you for a second, if you're familiar with it, is a book entitled A Framework for K-12 Science Education. This was written prior to the writing of the Next Generation Science Standards, and it was written 1.5 years before the standards and was the document used in order to come up with the grade levels. In other words, it was determined what students needed to know, what they should be doing, what they should be able to do, and then the Next Generation Science Standards put that together kind of into a grade level format. And between those two documents, they both talk about this novice and expert level. And one of the things that was very interesting is when we look at the next generation science standards, there's really these three parts. There's the practices of science, there's the content, and then the big concepts of science that we're really kind of looking at in each standard. So one of the things that they talked about were the practices, the skills of scientists. What do scientists do in their jobs? And one of the things that they talked about was the idea that children have lots of intuitions, and these are young children, grades K through 5 and younger, who they come up with these various kinds of intuitions to be used as a foundation that they use to build their understandings. And as teachers, what we want to do is to take the understandings, the prior understandings, whether they're misconceptions or not, and help move the student forward. So kind of back in the day, it was often thought that when you work with students at the lower levels, K through 5, all that you really want to do is to work on describing. Well, what we're actually finding out is that it's really important that we work on all of the practices that are in, the 8 practices that are in the next generation science standards at all grade levels, that students who are in kindergarten, first, second grade, that they are able to apply in their own way the 8 practices. So what this is doing is this is really building this novice scientist in a sense, which is using the basic skills through the 8 practices and then building up to the expert level. But another piece that they talked about is how this is all tied to content knowledge, that you don't do the practices in isolation, the skills of scientists, what we used to call inquiry, that it's really important that they're tied to content. And that was one of the reasons that we moved away from the term inquiry for the next generation science standards, because often what we saw in school is that at the very beginning of a course, students might do a lot of inquiry, and then the rest of the course would just be content. So it really has to be all of the 8 practices that scientists use need to be embedded. Well, one of the things that we found as far as novices are concerned is that a novice person in science very often had these disconnected, contradictory bits of knowledge. They have isolated facts. But what they do is they have a hard time putting them together, integrating them, trying to make sense and organizing that information. Whereas an expert really has an understanding of the core principles or the theories involved in science, and they can construct their own meaning, and they can also use them to process new information. So this idea of going from a novice to an expert is kind of so far kind of like 2 parts, and that is, as far as the practices are concerned, whether it's a novice or an expert, you want to be working with all of the practices because they will be developing those at different levels. But also as we tie those to content knowledge, that the novice will very often, as they're working with the content, they'll be able to pick it up, but they'll see that it gets disjointed, disconnected, and contradictory. Whereas the expert, as they continue to work with those practices, are able to apply those principles and apply the theories as well as they work with new problems. And there was a nice comparison that was done to somebody who's studying the violin, that a novice, if you think of a novice violinist, they pick up the skills. They're using the same practices, for example, that will be used by an expert, but at a much lower level, whereas the expert is still using those same skills as they play the violin, but they're able to apply them in a much different way. So as you look at that, particular slide, the idea of going with deeper understanding and application, it's really, I think, trying to look at that idea of going from the novice level to the expert level. And one of the ways to do that is to really immerse students into the practices that are in the next generation science standards. So this takes us to a question, and we'd love to hear what your comments might be. You can do that either through chat, or you'll notice that you can raise your hand. If you'll notice, you have a button that says raise hand. If you click on that, we'd love to hear from you. And this question is, from your experiences in Globe, what specific examples do you have of students moving from novice to expert? And as you maybe are contemplating this idea, I might just kind of share an idea of weather, that very often we have students who are collecting information, like at the lower grades. They're collecting weather information. They might be collecting daily temperature. Let's just use that, min and max temperature. But as a senior in high school, they're still taking minimum and maximum temperatures on a daily basis. But what's the difference? What does it look like that it's different at the novice level versus the expert level? So let me stop and see if you have some comments that you'd like to respond to this question.
While everybody's thinking, this is Marcy, and I have an example of how within a single classroom and multiple years of the same grade, a teacher can actually help bring their students of the same grade from novice to expert, and that's from a third grade class that we worked with that did the green down protocols. And I got to visit this class the first year they ever did the green down protocols, and they presented their research at the end. And the students got up and they said, our hypothesis is that our calendar says that the 21st of September is when fall starts. So that day the leaves will start changing, and about 2 weeks later they'll fall off the tree. And that was based on the experiences that they had. About 2 or 3 years later, the new third graders in this class came to our university to present the same project but that they had done. And they actually had 2 different hypotheses about the leaves will begin changing about this date, and the leaves on this side of the tree will fall sooner than the leaves on this side of the tree, and this side of the tree will change this color, and this side of the tree will change this color. And I asked the little girl at the booth, so how did you come up with these hypotheses? And she said, well, we reviewed the data from the last couple of years, and we knew that this year would have some things that were different, but some things that were the same. So in that case, just having more globe data available to them allowed these students to jump ahead to become more towards expert than the students who really hadn't had any data to begin with.
Great. Thank you, Marcy. Any other people like to comment? Oh, Svetlana just said that I can see the range comparing our students who are just starting in GLOBE and the experienced GLOBE students who presented at the GLOBE conference. That's very interesting. Thank you for sharing that, Svetlana. Any other comments that people might have?
Oh, Susan has her hand up. Go ahead.
Can you hear me?
Yes, perfect.
Okay. I just remember from a while ago when we used to do the pH of the rainwater, and just how much easier it was to really get the students to understand the meaning of it and to conceptualize the whole ion relationship, and I know that really helped a lot to make them understand what was what it was all about, the acids and bases and calibrating and all that.
Susan, one of the things that, as you're talking about, it makes me think about this whole idea of novice to expert. A lot of times in schools, we'll know that elementary students aren't able to have science, and I don't know what your experiences have been.
Yeah, that's what it is here.
If they don't have those novice skills to begin with, it makes it very difficult to move up to that expert level. I don't know what your thoughts are on that.
Yes, that's what happens here a lot. The elementary teachers that are not comfortable with the science, and very little gets done. And that's my role this year, is I'm concentrating on K through 6 STEM outreach. So.
Great. Well, thank you. Any other comments? Maybe time for one more?
I think what you just said also speaks to the importance of GLOBE providing some resources to help teachers make that step into the next generation science standards. For middle school teachers who are applying it the first year, again, their students won't have been through kindergarten through 5th grade or kindergarten through 6th grade of the next generation science standards, so they won't have done all of those stepping stones, and it'll be a bigger leap in the first years of implementation. And the more we can give to help teachers prepare their students maybe for those practices, the easier that transition will be.
Erin, you had a comment you wanted to share?
Yeah, I just wanted to follow up on that. I think it's a shift not only, this question is specifically addressing students moving from novice to expert, but I think, we're going to see a big shift in the teachers, right? And that's what you were alluding to, I think, early on. But, helping the teachers move from novice to expert in terms of helping the students learn the scientific practices. I don't think many teachers have as much practice at this as that we would all like.
Right. Thank you for sharing that, Erin. Well, let's move on, and I know Marcy has some comments about this next slide, about deeper understanding. And the 3 C's that you see there stand for career, college, and citizenship. And one of the things that you'll see as you visit the Next Generation Science Standards, and if you visit nextgenscience.org, if you haven't looked at them a great deal, of course you can go to that website, nextgenscience.org, and download them. You'll also see that there are accompanying documents, and one of them deal with career and college readiness. And we know how important that is, and we know that exams that students are taking are adjusting, and they're not just assessing content anymore, but they're assessing the practices and the big ideas of science. But one of the C's that often is not included is that is citizenship. We know that when students are done with K-12, that they have to go and move on to some sort of career, and that may include college, may not include college, but we're all going to be citizens of our community, of our state or province, of our country, and of our world. And it's really important that as students come out of school, that they're well prepared as citizens to make decisions that deal with scientific investigations, scientific understandings, scientific problems. Marcy, I know you had some comments you wanted to share on this.
Yeah, I wanted to share kind of 2 points about this slide, and one of them, I'm supposed to share my webcam starting now, just a minute. And one of the things that I wanted to really focus on is that this quote comes from that framework document that David showed you, and I'll show you my copy as well. This sits on my desk, and I turn to it several times a week, so that might be someplace for everyone to start.
Hey, Marcy, if I might interrupt,
yeah.
Just in case people don't know how to get that, if you go to the National Academies Press website, you can either purchase it for, I think it's $49, or you can download a free PDF of the document.
Yep,
okay?
and I think
Thanks,
you
Marcy.
can maybe see that both of us have the free PDF copies that we printed.
Yes.
So this quote came from the framework, and then it was reused again in the appendix of the Next Generation Science Standards. So just a reminder that the standards themselves came out of the framework, and they look back to the framework over and over again. And then this slide also addresses why we decided that we wanted to put the deeper understanding and application of science and the college career and citizenship ready together as a theme. In these 2 conceptual shifts, what we're really recognizing is that if we have a deeper curriculum, not a really wide curriculum, but we learn the things we learn really well and we're able to apply them, then we're able to be college, career, and citizenship ready. And this quote, which is in the deeper understanding section of the appendix, really explains why NGSS allows us to address the other concept of preparing for life. At the beginning, I didn't share anything about myself. So hi, I'm Marcy Seavey. I am the program director for the Iowa Academy of Science, and a part of that role means that I'm also the state coordinator for the GLOBE program. I've done that since 1999. And like David, I was on my state review team for the Next Generation Science Standards. So we spent about the last year, or a little more than a year, reviewing all the different drafts of that and contributing to that. And I'm also on my state Science Leadership Team Task Force, which is the group that helps decide what professional development our PD leaders need to prepare for everything that the Department of Ed rolls out. And we're gearing up right now because in Iowa, we're about probably 3 months behind Michigan. We have a task force which is researching the Next Generation Science Standards, and then they will make an suggestion to our state board, and then they'll vote on it, and then the hope is that we will adopt them. So that's a little bit about my history. I actually wanted to start with my question for the group to think about. And when we were discussing preparing for this presentation, one of the things we talked about is that a lot of the time we consider that we're preparing our students for their next year, or we're preparing our students to go to college, if we're high school teachers. But we maybe don't think as often about how we prepare our students to be citizens. And so I wanted us to think about and share our ideas about how does GLOBE prepare students to be better citizens. And I'll give you a couple of moments to think about that, and then again you can type your discussion into the chat window, or you can raise your hand and then use the voice. So Dorian says, I think it helps them immensely to share and participate with other students around the world. And Julie says it makes our students aware of their environment. Todd has raised his hand. Go ahead, Todd.
Hi, can everybody hear me?
Yes.
Yes.
Okay. Basically, I'll just go back a couple of years when I was still in the classroom here teaching GLOBE. I had students doing some research on some water. We're down at a stream. They find that the readings that we've been looking at for years, past students, that they had readings that were terribly different from other groups in previous years. And long story short, there was a gas station that was upstream, so to speak, and their tanks were leaking. So the students were able to kind of say, hey, we found this, and they can start to take part in decisions and things that are occurring right in your own little town or community.
Oh, that's really great. And yeah, when the students bring their presentations to the GLOBE student conferences or to the GLOBE International Conference, one of the things I always notice is that kind of maybe unlike some of the science fair posters or presentations that I see, every GLOBE project seems to connect to the community. They'll have, a part of the community is part of the reason why they decided to do that research in the first place, or to go from just collecting data for GLOBE to asking their own question. And then they often present to the community some kind of solution, something like that. Thank you very much. Any other ideas about preparing students to be better citizens? I think for me, another thing that GLOBE does is that in GLOBE we always do get to that communication step, and in a lot of other science classrooms, a lot of other things that students do in science, they do the whole project and turn in a lab report and then it's done. And they don't really get a whole lot of experience communicating what they learned, having other people respond to that, and then having to defend their evidence. Dorian adds, I would also add that it makes them engage stakeholders when they have directly interacted with their home planet. Definitely. So I have a follow-up question, and that's to go to that bigger idea about how does GLOBE help prepare students for college and career? And is that different than preparing them to be citizens, maybe? Oh, Svetlana says, echoing the last comment, we will be intentionally addressing this in the 12th grade year by facilitating community-based projects based on what they have already learned through GLOBE. One student testified in a regional planning meeting. Oh, that's fantastic. Yeah, talk about being prepared. So if we add to this question, how does GLOBE prepare students for college and careers? Todd just raised his hand.
I'll just mention again, having the students, they were juniors and seniors, basically doing some of the GLOBE protocols in land use and remote sensing, and some of the students got so into it that they actually went to college in those areas of like GIS and those things, and got jobs as city planners.
Oh, that's wonderful. So inspiring their future aspirations.
Yeah, I mean, it's kind of cool to see when the light bulb goes on there.
I know for myself, whenever I go to seek funding for my partnership, I go back to, I believe it's the second or third year GLOBE evaluation. And in that evaluation, they looked at the skills of, I could have the grades wrong, but I think it was 4th, 8th, and 12th grade GLOBE students and non-GLOBE students. And what they found is that the GLOBE students were better at taking measurements, so using a ruler, using a graduated cylinder, and that those students were better at reading graphs and interpreting graphs and data. So I think some of those basic skills that you need in order to collect data and to analyze data is something that would prepare students for for middle school students for high school and high school students for college, and then also perhaps for careers in the science. And I have a really long wait time, so I'm waiting for a couple more comments on how GLOBE helps prepare students for college and career.
Hi, this is Erin. So one thing I'd love to add with that, there's some research out there that says one of the big reasons students don't persist in college is because they have a hard time with communication and group work and finding study groups and doing some of this collaboration that is so necessary when you're taking GLOBE data. It's hard to take good GLOBE data and really think deeply about it if you're doing it by yourself. So I think it sets them up for college in working in collaborative groups, doing some teamwork, problem solving with the equipment perhaps, or with their their peers.
Oh, that's a great point. That'd be a great thing for us to look into as a new research project. All right, so this idea of college and career ready and citizenship ready has its roots in and is connected again to that deeper understanding. And I actually have my roots in environmental education, and I think that in environmental education we've had some of those same ideas rolling around for a really long time. As we think about how to succeed in environmental education, a lot of times one of the first things we do is just get people out into the environment and then try and and that would be like very novice, just stepping out and asking questions. And then you do even better if you can get them to have a hobby that involves being in the environment. So hunting, fishing, canoeing, kayaking, hiking, geocaching, all of those things. Just by doing that, you become more and more connected to the environment, and then that allows you to make kind of ask more questions and maybe make some wiser decisions, again, because you're stepping from that novice stage to that expertise stage, and also that is in turn helping you become a better citizen of the environment. So on this next slide, we're going from this idea of how GLOBE helps us move on in college and career and citizenship to some of the resources that are built into the next generation science standards to help move students to college, careers, and citizenship. And so on this slide, at the top of the slide, the multicolor statement is one of the student performance expectations. So that's the main body of the standard. And this would be third grade physical science standard 2-1. And the standard is that this is what the student will be able to demonstrate. So the student will be able to plan and conduct an investigation to provide evidence of the effects of balanced and unbalanced forces on the motion of an object. So that's the thing they're going to be assessed on. The standard itself, actually in the very bottom boxes of the standard, connects that statement to their English and language arts literacy and their mathematics standards that are related. And I didn't actually put all of them because it was far too much text. So I picked out 3 of the literacy and math standards for this specific student performance expectation. And so in third grade, in language arts, the students are expected to know how to ask and answer questions, to demonstrate understanding of a text, and refer explicitly to text as the basis for their answers, to conduct a short research project that builds knowledge about a topic, and to recall information from experiences or gather information from print and digital sources and take notes and sort evidence. All of those things that they're working on in language arts in third grade are skills that they will use and build and demonstrate when they plan and conduct their investigation about balanced and unbalanced forces. So the science and the literacy are backing each other up in this case. And the same thing with mathematics. So in mathematics' core is a little bit different. They have some overarching principles that would kind of be like our cross-cutting concepts. And then they also have grade level standards. And so their 2 overarching principles are reason abstractly and quantitatively, and use appropriate tools strategically. And again, when they're planning and conducting that investigation about the forces, they're going to select the tools that they're using, and they're going to have to use some kind of strategy to do that. And then in third grade, one of the math standard connected to this is measure and estimate liquid volumes and masses. So it would be the masses part of that standard in units of grams, kilograms, and liters. And so that fits really good with GLOBE because we're using grams and kilograms instead of pounds. Add, subtract, multiply, and divide and solve one-step word problems. And really their investigation would be an example of one really big word problem. And use drawings to represent the problem. And again, so if they're communicating that investigation that they planned and conducted, they're probably going to use some kind of graphs or drawings, illustrations to do that. And so again, the mathematics is backing up the science, and the science is backing up the mathematics. And so the idea is that as if students do this in this progression, we kind of talked a little bit about this topic last time too because that was the progression. If they do this and they move from novice to expert, and all of their all of their subjects are integrated or help build upon each other, then they're going to be more ready for college, they're going to be more ready for careers, and they're going to be more ready just to be citizens of the world. So it's important, this is a really important concept for providing students a comprehensive education which prepares them for college, career, and citizenship. Knowing a lot of facts about a topic doesn't serve you well if you can't communicate what you know effectively to others. By aligning language arts, math, and science, NGSS provides us with the resources we need to deliberately integrate across the curriculum. And when we talked about building that deeper understanding and moving from novice to expert, when you gave your examples of that, and when we talked about citizenship, we were really talking about integrated curriculum. All right, I am going to turn this over to Kristen to lead us through some brainstorming questions for this session.
Thanks, Marcy. Appreciate it. Hi, everybody. I'm Kristen Wegner. I'm a project manager at the Globe Program Office. And we are now going to go through a series of questions. I'd like to hear from each of you, so please follow the same procedure. Raise your hand or chat anything, and I'll read whatever you put into the box. We've gone through these questions before in the past webinars if you've participated. And so this time, now we're looking at it through a different kind of framework. Now, everything that we've gone through for the past half hour, 40 minutes, from novice to expert, and also college, career, and citizenship, I'd like you to consider those kind of ideas. We can talk on the self one too. And so think about those as you answer and contemplate these questions. So the first one, what will teachers need to know about GLOBE to address NGSS? And so think about it as a teacher yourself. I know we have a lot of partners in the webinar and also in teacher trainings. What types of things will teachers need to know about GLOBE for NGSS? I think this is a huge opportunity as an organization, so I'm just curious how you envision it. So Susan says they must be trained in some of the protocols. Yes. I'm curious which ones or how you think the protocols can be tied to NGSS, or what's the compelling thing with the protocols. Julie says available resources, all the various options of things to do with GLOBE. Great. So a couple examples, what specific options come up for you? I don't see any hands raised.
I see Camille, and actually Todd had his hand up and it
Oh.
was down.
Okay, good. So Camille first.
Well, one of the things that just came to my mind was regarding GLOBE protocols. I think that in order for them to really do NGS correctly and the science practices is not just the protocols, but what doing those protocols correctly means to GLOBE and to the science that's being done, so that not only do they feel that they're providing good information, but information that they might get to do a project regarding, temperatures that might have been taken in Africa, that they know that they can trust that information. So I think that would be another very important thing. It's not just do the protocol, but how important it is that the protocol be done in a correct manner because it's so important to other people.
Hey, Kristen, This is Dave. I was just going to follow up. That's really an important point because, one, if we're talking about the practices, are skills that scientists and engineers are using in their everyday life, they're not doing things inaccurately. There would be no reason to rush to get that. Well, I guess it could be. But it also makes me think of how many times we've seen students share information, but the information is incorrect. And I know that in the science, I think it was Science Scope or Science Teacher this month, it's a focus on argumentation so that students share their data, but students and others can question the data, and so that a student has to make sure that they're collecting data accurately, before they present it to others. So that was a very good point. Appreciate you sharing that.
Great, thanks, Dave. I took a couple notes when Marcy was leading the questions, and some of the things that came up were the communication step and defending evidence and the testifying about it. And so when I think of the protocols, it's actually doing it and knowing that you can trust it, but then what do you do with all that and following the practices? So thanks, Dave, for elaborating on that. Dorian? Dorian, are you there still? Okay, let's move to Todd, and then Dorian, if you come back, raise your hand and we'll get back to you again.
Well, they took most of my thunder already here. That's why I put my hand back down. But just to kind of go along with it, again, teachers are going to need to know the knowledge of the protocols and kind of how they fit into their local curriculum before they can kind of relate them to the next generation science standards. But other than that, everybody else took my point.
That's great. It seems like we have very similar thoughts. I see also in the chat, Dorian says they'll need to figure out how to integrate GLOBE program protocols into their existing curricula. And Julie says very similar, to tie the protocols into lesson plans. So now, Dorian, maybe you'd like to elaborate on that connection also. I see your hand is up again. Oh, yeah, we can't hear you. I'm sorry. Check and make sure that your phone is not on mute. Oh. Now
Hello?
try that. Yes.
Hi, this is Dorian. Can you hear me? Okay. My goodness gracious. Yeah, I was just going to say, having been a classroom teacher for 33 years, you know, it is so hard when you have already a packed curriculum, you know, to then find how to implement and then integrate on an ongoing basis something as intensive as the GLOBE program. But I think that if we can get teachers to try little bits and pieces of it, they'll realize then that, you know, that they can do bits and pieces, and also that it actually is going to be a much more engaging and you know, exhausting, exhaustive, as in they will cover all the indicators that need to be covered. But I think we need to make it more user-friendly initially to get teachers to put their foot in the water.
That's a really good point, and that actually brings up to the second question. Thinking about that, how do we, as GLOBE, provide resources to help teachers to address the NGSS, and keeping in mind what Dorian just said of how it could be daunting and giving them chunks or little pieces to get into it. How can we help that, or what resources should GLOBE provide?
I think that, this is Marcy, I think that NGSS really provides us an opportunity to do this well, because one of the things we can remind teachers about is that this is a deeper curriculum, which also means it's not as wide. There are far fewer things to cover in any given year. They may have their very favorite activities that they've done in the past, but those might not be connected to anything they're going to teach in that grade now. And so theoretically, that curriculum should become unpacked when they do NGSS. And suddenly they're going to say, oh my goodness, I have 5 weeks or 10 weeks to cover these 1 or 2 topics or concepts. And so that gives us an opportunity to say GLOBE is a great tool for doing that, because it is also deep.
Marcy, I think we lost you for the end.
There you are. It is also deep. Hopefully we got it.
I think I lost you again.
Go ahead and go to Todd.
Okay. Okay, thank you. Really good point. Let's move on to Todd, and then Camille.
I think some of the e-learning modules that GLOBE's come out with will be a great way to get teachers, hey, what's this program about? Hey, this is kind of a neat program. I might want to learn more type situation.
Great. So great to hear that online learning can help with that too. So teachers that might think it's really intimidating, this NGSS, how do I do it? But then to know that they can just be part of a community, an international community that's already doing this and already implementing the NGSS in various ways. So it'd be great to get them through that. Thanks. Camille?
Yeah, I've been trying to think, and you guys may have mentioned this. I missed the first seminar that you guys did,
Yeah.
but I really think that if we were to able to match specific GLOBE activities or GLOBE protocols, because it's no longer just the content, oh, we're doing the ocean or we're doing water.
Yeah.
That protocol might be able to work with, life science 3.2 or, whatever. But I mean, if we were to do that sort of, believe it's technically called unpacking like somebody else said, but match them, but in such a way that this GLOBE protocol could help you with this one, this one, this one, and this one. So it has the potential to, depending on what you're doing, help you out with this performance standard or this performance standard or even just this practice. That sort of a thing would help whether we had a teacher who didn't know anything about GLOBE or we have teachers who do know about GLOBE but they're nervous about the NGSS.
Great. And that's a really good point. Marcy will speak to that in a little bit. Because you're reading our mind, we have a workshop scheduled for November that Marcy will talk about where we're going to go through that and align each of those things and have a product that teachers could just look at. So that's a really good idea. Susan says GLOBE should provide a crosswalk with NGSS practices. Again, that goes back to, Marcy will talk about that in a second too, of what our plans are for that. And then Marcy says the online student reports are case studies of how GLOBE is used. Marcy, can you talk a little bit about that? Because I know we've chatted about that in the past, but I think it'd be helpful to
Yeah,
hear
I think that whole, like when you first start in GLOBE and you're learning the protocol really, really well, that's what gets focused on in the workshop. And then you go to do it, that your kids go out and they start collecting data and they have their own questions. And what we hope is that they turn their own questions into their own investigations. But sometimes maybe a teacher can't envision, if they're new to GLOBE and they haven't done anything like this before, they might not envision even that they can go on with their students and answer their own questions and do their own investigations. So if we can draw them to those reports or maybe even change how we display those reports so that they can see this is how GLOBE is working in classrooms where they're going beyond just collecting the data and they're doing things with it and they're collecting additional data or going to other student data or NASA data or NOAA data and adding it to their GLOBE data to answer their own questions. And then that really gets them to that practice, content, and cross-cutting concept all together.
Great. Thanks, Marcy. I just think about modeling, and when you're going to teach and you model it first and then have the students look at it or the professional development. And so I think it's great to have the case studies as a full context of what is possible and taking it a little bit deeper than just identifying this is how it fits, but seeing the whole picture and story together. We're going to move on to the third question now, which kind of builds on that with the case studies and resources. What should an NGSS professional development or PD session during a GLOBE workshop look like? I hear typing, but I don't see any hands up, so feel free to just jump in. Okay, Julie says case studies and sample lesson plans would be great. So actually detailing it out of what would happen in a classroom or for a day or for a longer period of time of how that scaffolding would happen. Camille?
Again, maybe a session of how GLOBE really helps them solve helps them with the science practices. So I like the idea of having specific activities that we could do, but also maybe some kind of a professional development where we take these 8 practices and show where GLOBE really will help them with those 8 practices, even if they aren't following a specific activity.
So it sounds like having the teachers in professional development actually go through the practices.
Right.
Okay, great. Svetlana says, building on Dorian's comment, show how small activities fit into the bigger learning objective, color coding the protocols to the practices, content, concepts, other visuals to see how it maps out. As others are suggesting, and yeah, that's great. Just to jump in on that, we're also looking at what our product will be and how it'll work with other resources that are out there that are doing that. And PD, that has teachers actually work on their own lessons. So I'm hearing that again too, of actually having them go through that practice of developing the lesson and probably reaching out and having other people review it and going through that within the PD session.
I really like that idea as well. I think if in the workshop the students, the teachers, can learn how to use a protocol and then be expected to use data from that protocol to present, to communicate something about what they learned over the week of collecting or the however long a period the workshop is, and then write up their lesson plans or their unit plans in which they make those connections between the two and respond to each other. That's a really good activity.
Yeah. I've actually done that in PD sessions as a participant, and it was more of a transformative experience when you actually have to go through and then look at what you did and see how that aligns or where you missed parts of it too. Anybody else? Julie says she also likes the color coding idea. There's a lot of really nice visual displays of NGSS, and so I think it's helpful for us to look at our product too and how we can fit into those. Let's see. Any other final comments on this question? Okay. Well, thanks for participating in this conversation. If anything else pops up, please feel free to type it into the chat window. And so right now we're going to pass it on to Marcy.
Okay. And so I'm going to really quick review some of the resources that we use today. And one of them that we referred to a few times is the Framework for Science, K-12 Science Education. Can you confirm that you have me, Kristen?
That I have you?
Can you hear me?
Yeah, I can.
Yes, we can hear you.
My camera is locked up, so I'm actually just going to close it.
Okay.
Oh.
Oh, now I see you.
Fine. Okay.
Yeah.
Okay. So some of the resources that we use today or that this session came out of. And one is to remember to go to the GLOBE website and visit that teaching and learning section and the learning standards for links to the actual standards and some other resources. And also, if you are a U.S. partner, to go to the U.S. Partner Forum and the additional NGSS implementation resources are there. So those are things that maybe we have decided aren't ready yet to be used in workshops or integrated into the full GLOBE website, and we want partners to have a discussion about them before they end up becoming part of the regular website. And so that's in the Partner Forum. Also today we talked specifically about content that is in Next Generation Science Standards Appendix C, College and Career Readiness, and L and M, which are connections to the language arts and the math Common Core. And so that might be a place to go learn more about those two topics.
Okay. You just need to do it from here.
Then I'd like to invite you all to consider applying to become a part of our GLOBE program and NGSS alignment workshop. We've talked about this at all the past webinars. It's a 2.5-day working meeting of our dedicated, diverse GLOBE community members. And what we'll be doing in that time is we'll actually be creating that alignment between the protocols, the activities, and some other GLOBE resources like Elementary GLOBE and some of the website resources and the NGSS standards. Thank you very much for joining us today, and mark your calendars for our next webinar, Wednesday, October 9th, 2013 at 1 p.m. Eastern. And this recording will be posted to the webinar tab later today or in the next couple of days. Thank you again, and we'll turn the recording off.
October 9th, I'll be here.
Yeah, thank you.
Yeah. But you know, it's a learning curve. I've never heard of reading before. And I don't, it's kind of old-fashioned.
Thank you. Please stand by.